Okay, the t-distribution. First off, the t-distribution, just like the normal distribution, is mound shape and it's symmetric about 0. However, the t-distribution has a completely different distribution for every single different sample size. We like to say for every single degree of freedom, but degree of freedom just happens to be the sample size minus 1. All right? However, as our sample size increases, so as n goes up, the t gets closer and closer to the normal distribution. Let's look at the formulas. First off, the z distribution, when we're working with central limit theorem, is x bar minus mu sigma divided by the square root of n. Now, to use this, we either had to have an underlying distribution that was normal, or our sample size had to be 30 or larger. The t-distribution looks very, very similar. X bar minus mu s divided by the square root of n. So when we take a look at these two things, they're almost exactly the same. The only difference is this has the standard deviation of the population and this has the standard deviation of the sample. So we use the t-distribution when we don't know the standard deviation of the population. We use the t-distribution when we only have the standard deviation of the sample. Now, most of the time, we're not going to have this. Rarely do we actually know the population parameter, so we usually have to work with the sample. So this is what we usually have to work with. All right? Now, as n increases, the t gets closer and closer to the normal. All right? But it is never truly normal. It approximates the normal. But if you remember, we said the conditions to use the normal was this had to be, the underlying distribution had to be normal, or the sample size needed to be 30 or larger. Guess what? To use the t, the underlying distribution must be normal, or we have to have a sample size 30 or larger. It's almost exactly the same. Now, the t-distribution is a fatter distribution. It has more variance. There's more area in the tails. So if this is the t that I have drawn right there, a normal centered on 0 would be a little bit taller. It has less variation. So the t has more area in the tails, where the z distribution or the normal distribution is taller and more data around 0. All right, so greater variation for the t, less variation for the normal. The only other thing you really need to know is make sure that you know that the degrees of freedom is n minus 1, or the sample size minus 1. Whereas when we were working with the normal distribution, all normal distributions you could use the empirical rule, and we could say that 68% of the data was plus or minus 1, 95 was plus or minus 2, and 99.7 was plus or minus 3. On the t-distribution, that's not true. The percentages change for every single sample size. So if we have a larger sample size, we get closer and closer to the normal, so we start to approach the empirical rule, but we never get there exactly. But we get really, really close. But once again, the z distribution or the normal distribution, the empirical rule applies. It does not apply for the t distribution. In fact, as I said, every single t distribution will have a different percentage based on its sample size.